And you don't pay attention.
All right, just quick. This won't take long. I realized, so I remade assignment 39 because I didn't like it. And so I spent a good chunk of time yesterday and reconstructed the whole thing. Wasted a whole bunch of copies, but it was worth it. So the question that I just made myself a note that I had to bring up today was, how do you graph a line on a grid like this when your normal method of graphing it would fail? So I mean, you can write this down or not. It's up to you. I just want to have this in your mind because this will happen to you a couple times on this worksheet. And so how normally would we graph this line y equals x minus 6? Where would we start? Right. And you can see therein lies the rub, right? That's not possible to go down 6 on a graph like this. So I felt compelled to go over this with you. Let's problem solve this together. How do you graph a line in the normal method when the y-intercept is not available to you? I mean, you certainly could do that. You could try to visualize where the y-intercept is going to be. The trouble is the y-intercept is, let me see if I can just move this. The y-intercept is down here someplace, right? So, I mean, if you're a good visual sort of learner, then you could project where the line is going to go, right? And so I just wanted to tell you that there are ways around this. And number one is, yeah, just do what Kyla said. Just go up by one, right by one until you get to where you think the graph is. The other thing I just wanted to tell you is just start messing around with points until you find one that's on the grid somewhere. Because all of your graphs on the assignment are quadrant one graphs. So there's no negatives in quadrant two, three, or four. Everything is positive, positive up here. So I was just going to say, like, imagine you just picked an X like 10 and you put it into the equation. What is 10 minus 6? So we could say for sure that the point 10, 4 has to be on this graph, right?
Interruption, can we have
So,
all of the red
so I
words
could
in the
go,
comments, please?
so I could go right 10. I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, like this, right? And then that's not enough, obviously, but if you know the slope, it is enough. But if you didn't want to talk about the slope, then you could just do the same thing again. You could pick a point like 15, right? And then if you put 15 in there, what's 15 minus 6? 9. And then you can say that the point 15, 9 also has to be on the graph. So I could go to 11, 12, 13, 14, 15, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's lots of workaround sort of ways. You can involve the slope in it, things like that. But I just don't want there to be any panic when you go to graph a line in your normal method, because normally we would just go down 6 and then go up one, right one. But, that's not the only way to graph a line. And so that's one possible strategy I just wanted to give you. So maybe the world's shortest recording. I don't know. I'm going to pause it, but you guys might have questions once I hand out the assignment. So I'll keep the recording going just in case, but just wanted to show you that. So all hope is not lost if you can't see the y-intercept. Just get creative and find a couple points. Just simple in and out stuff. You pick an X, it gives you a Y. Easy peasy. I'm going to go through problem one if anyone's interested, just to make sure we're all on the right track. If you feel like you're cooking, don't sweat it, but you might want to come along. It's up to you. So our first problem, we're going to move the 2x to the other side. And then we're going to divide everything by 3. And when you divide by 3, you get y is still less than or equal to negative 2 divided by 3x plus 45 divided by 3. So that's what this one should look like when it's all good to go. So that one kind of takes the place of that first one there. So we don't need to worry about this one anymore because it's been modified now, right? And then the second one, we're going to move the x to the other side. And then we're going to get y is greater than or equal to 1 divided by 3 times x. So are we good on that part? Okay, so the math is going well. So again, this takes the place of the first one. So the first one can be omitted from in its original form. You okay?
Yeah, it's just one.
Oh, I thought you poked yourself. Okay, so let's talk about this purple one first. So the first thing I like to do is label, and I don't label them all. I usually just will go like every five or so. So I'm going to go like 1, 2, 3, 4, and then I'll mark 5, 6, 7, 8, 9, mark 10,
Yeah,
11, 12, 13, 14. So you marked like 3, 6, 9. Sure, absolutely. Yeah. And kind of to each his own in a case like that, you know. The bottom line though is you really should label something. Like, I mean, how frequently is kind of up to you. So I'm going to start my first graph at up 15, which is right here. And then the slope is down to right 3. So these points here are all representative of the first boundary. And again, no need for like arrowheads because we know that these are all going to just exist up here. And because it says less than, then we know that the shading will eventually go down below the line like this. You want me to give you a second to get caught up and fix it? Hold on a second. I got to ask a question. Did you make every tick mark worth 3? No, you shouldn't do that. So the reason why your graph is going to be really hard to read, so I want you to fix it real quick for me. We should not unnecessarily scale. The problem with you going by 3s, and tell me if it doesn't make sense, I'll try to explain this again. Your whole graph is going to exist right here. And that's what we always want. A good grapher wants to avoid cramping all of their stuff into one little baby corner. So that's why I tried to give you pointers. You'll notice like on problem 2, I said right here, go by 2s. I'm sorry, I thought when you said you went by 3s, I thought you meant you were labeling it like 1, 2, 3, 4, 5, 6, like that. I didn't realize you meant literally every. So don't scale something if you don't need to. We want to be aware of how much room we have on our paper. And since we have a 20 by 20 grid, then we should only scale if any of our intercepts are going to go above 20. So I'll give you a second to fix that. Okay, so one line down. Now let's talk about the red one. The red one has a y-intercept of 0. You just don't see it, but it's there at the end, right? So like plus 0. So we're going to start our red graph at 0. And then it has a slope of up 1, right 3. So we're just going to do a bunch of points. I like to just go as far away as I can, like that. And then I'm going to make my line. And this one, because we remembered to switch our sign, says greater than or equal to. So I'm going to just, again, draw some little indication arrows to remind myself that the shading will eventually go up in here. Still with me? Okay. And now X only is a vertical line. So I'm going to go to 12, and I don't have my X-axis labeled, so I'm going to do that. So I'm going to go to 12 and make a vertical like this. Correct. Yeah, to the left, right? And so I don't need any extra arrows above or below. I really only need to worry about the right, the region that I know it's going to be in. And then X is greater than or equal to 3. We have another one. So we're going to go to 3 and draw a vertical. And that shading again goes in. So we're going to go up to 10 and go across. And again, the shading is down. I tried really hard when I created these. I hope I haven't finished my answer key yet, but I checked it and double checked it in the hopes that I wouldn't have any blunders. So the shaded area is going to be the stuff inside the boundaries, like from here to here, and then here to here.
It was just the way I scaled my graph.
That was probably it, yeah. So don't scale unless you need to, please. That's wasteful. And what we want is we want our graphs to be as spacious as possible, not because it's artistically pleasant, but because we can do more, we can get more information out of a graph that has a little bit more real estate. I don't know if that makes any sense, but we don't want to be trying to make sense of something that's crammed into a little corner. So that's the way that should look. That makes sense?
Yeah.
So basically, we're just going to do this a bunch. Now, when you get to number two, I'm just going to get started on number two. I'm probably not going to finish it. But right away on number two, we see why the scaling has to go by twos. So like if we take this top problem and we move 3x to the other side, we get 2y is less than or equal to negative 3x. Right. And then when we divide by 2, we get y is less than or equal to negative 3 divided by 2x plus 40. And that's where it occurs to us that I don't have enough y-axis here to go up to 40. So that's why we're going to scale by twos. That's why I put that little comment there. So again, the way I do it is I just mark a 2 and then I just count 10, 20, 30, 40 like this. And then you can add in any other marks that you want along the way. And now anyone reading my graph knows what my scale is. And then I'm going to do it the same on the x-axis. Every good graph should have a scale. And if it's ones, that's fine. We still should label it. But the scaling is essential. Like you don't want to go into the graph, and you, bless you, you learn that in the first problem where like it's going to not end well if we're not aware of what we're doing. So the hard work I think is done. Like we've made our, I don't even know if that makes sense, but like that's an important first step. Is just to get it sensibly lined out. And now your job is to make sure you don't make any mistakes on the other two, because there's two more where we have to get y by itself. Are you with me?
I'm working on the second one.
Okay. So I'll work on it also.
We have to put this on.
We will indeed, yes. So if we're going to have and then when we divide everything by -6, we should get y is switch the sign. 1 divided by 6x plus 5. Okay, so that's another one now that's ready to go. And then the last one is this the fifth one in line, right? So again, I can cross off this original second one because I've already fixed it up. And then this one is going to be, we don't have to switch the sign on this one, which is nice. So if we divide by 6, we should get y is greater than or equal to negative 2/3 of x plus 10. Are you with me? Okay. So now these three that I have written up here in colors are the three that we have modified or fixed to make them graphable, right? Okay, so let's start with the purple one. So where do we start? Up 40. And then the slope, since we scaled our axes the same, we can count it just like a normal line. Down 3, right 2, it's going to work just fine. So 1, 2, 3, 1, 2. I mean, we're actually going down 6, right 4, according to the scale. But because the scales are identical, it doesn't matter. And we're going to be below that.
Second one.
Mhm. So this one, you just kind of have to guesstimate where 5 is. It's halfway between 4 and 6. So that is 5. And I like to make a mark. I mean, I like to number it for anyone reading my graph like that. And then the slope should be up 1, right 6. So we're on a tweener, so we're going to stay on a tweener. We're going to go up 1. You see kind of where my pen's at there? I'm still in between, and I'm going to go right 1, 2, 3, 4, 5, 6. So like that. 1, 2, 3, 4, 5, 6. 1, 2. And the graphing, the shading on that one's going to go above. So we can already see our region starting to take form. And then the last one's going to start at up 10. And it has a slope up down to right 3. I'll give you a little more time tomorrow for these. So if you guys are done, might want to find something to do.
And then the arrow.
Mhm. Right. What's up?
Supposed to be a fraction or number 5. Then I think I got that problem here. The rest are just easy.
Hang on, because I wanted to do it too. But I mean, yeah, that y-intercept will be a fraction. So it'll be 1 1/3. So just estimate that and it'll be no problem. As long as you're just a third of the way above 1, you'll be fine. Okay. So are we together so far? Okay. So now we're going to graph this, the horizontal at 30. And we're below that. And then you're going to see this one right here, the one I'm circling a lot, because that just forces us to not head left. So that's a really common constraint. Just you'll see it a lot in word problems when we start those, is that you just can't have negative quantifiable. So like, or quantitative, I don't know what the right word is, but like if you're counting something, like you wouldn't say I have -1 of them or something. So that's why an inequality like that will always exist. So an inequality like that is common just in that it forces us to not go a certain place. So like you'll see that a lot. Okay. And then of course you can see now where the region is. Like if you put all the shadings together, they clearly come into this little pentagon here.